Hello students, today we'll discuss IB Mathematics HL Paper 1 May 2019 Time Zone 1. No calculator in this paper. My name is Nariman Malim and here you can see my mobile and email. You should have with you the following source: Mathematic HL and further mathematic formula booklet for use in during the course and in the examination, first examination 2014. And of course you need only formulas for mathematic HL and don't need further mathematic HL formulas. This is the cover page, and in the cover page we see that you are not permitted access to any calculator for this paper. Section A. Answer all questions. Answers must be written within the answer boxes provided. Working may be continued below the lines if necessary. Let A be this vector, B is this vector, K is real. Given that A and B are perpendicular, find the possible values of K. From booklet we have formula for cosine theta between these vectors. And because cosine of their perpendicular, so cosine of 90 is 0, so their scalar product, which is above, is 0. And formula for scalar product is written here, also from booklet. Substituting the components of the vector, x, y, and z components of the vector, we get quadratic equation. The straightforward way is to use formula from prior learning, which is also in the booklet, and we get 2 and minus 3. Done. Question 2. Determine the first three terms of this exponent in ascending powers of x, given each term is in its simplest form. So section 1.3 of the booklet, binomial theorem. So here we have first term, second term, and so on. In the terms we have combination symbol, and combination are rewritten this way, starting from 0, R0, and this is R0, and this is R1, and so on. So A is 1, B is minus 2x, attention, plus, and here minus 2x, and N is 11. So the first term, according to these two formulas, will be 1. Second term, so combination, coefficient will be given by this expression. 1 to the 10th is 1, and minus and 2. So out of this we get 11 times 10 factorial, 10 factorial, 10 factorial simplifies. We get minus 22. Third term is given by this formula. Here we get 9 factorial simplifies with 9 factorial, 10 and 11. 10 and 11 is here, 2 here. Minus 2x squared give us 4x squared. 2 simplified by 2, you get 220x squared. So 3 terms we found. Done. Question 3. A sector of circle with radius r centimeters where r more than 0 is shown on the following diagram. The sector has an angle of 1 radian at the center. Let area of the sector be A and perimeter be P. Given that A equals P, find the value of R. So sections 3 are length of the arc. So this arc is given by theta R. Theta is 1, so it is R. Area is half, again section 3.1. Area is half TR squared. T is 1, so we have half R squared. Perimeter will be r plus r plus r, because we need total length. So perimeter is 3r. So half r squared. So area equals perimeter, half r squared equals 3r, and from which we deduce that r is 6 centimeters. Done. Question 4. The length of two sides in triangles are 4 centimeters and 5 centimeters. Let theta be the angle between the two given sides. The triangle has an area of so much centimeters squared. Show that sine theta equals so much. A. Solution. Section 3.7 give us area of a triangle in the form half AB sine C. So sine C will be 2A by A times B, and area, we substitute area, 2 and 2 simplify, we get square root of 15 over 4, so shown, done. Find the two possible values for the length of the third side. So we use cosine rule. From 3 to Pythagorean identities, cosine square plus sine square give us 1. It means that cosine will be square root of 1 minus sine square 2. Cosine equals, and we substitute the value of sine, and here we understand that when we square we get two roots, plus and minus, so we get plus minus 1 over 4. So two versions, plus and minus over 4, goes instead of cosine into this formula, so we substitute all values, and we have to make square root, so with plus and with minus, so separately with plus and minus and plus, so we get two values. This question is done. Question 5. A camera points at point C is 3 meters from the edge of a straight section of road as shown in the following diagrams. The camera detects a car traveling along the road at time t equals 0. It then rotates, always pointing at the car until the car passes O, the point at the edge of the road closest to the camera. A car travels along the road at speed 24 meters per second. Let the position of the car be x and let OCX be theta. Find d theta by t dt, the rate of rotation of the camera in radians per second at the instant the car passes the point O. So a right angle triangle, tangent will be x divided by 3. Opposite side by adjacent. So we have equation. Let's differentiate both sides. So first of all, tangent, when we differentiate tangent, we get secant squared x. But also we differentiate by x. So first we differentiate by theta, and then we differentiate by x, by time, sorry. So differentiate by, we use chain rule. And first we differentiate by theta, and then theta by time. So left side. Right side, 1 over 3 dx over time. So dx over time is actually speed, it is 24. So here we get, on the right we get 8. On the left we rewrite secant into 1 over cosine squared theta. Solve for d theta by d time. And we take a value at when angle equals 0. So when cosine equals 1, so this is 8 radians per second. Done. Question 6. Let x be a random variable which follows a normal distribution with mean mu. Given that probability that when x is less than mu minus 5 equals 0.2. Find probability that x more than mu plus 5. So because the graph is symmetrical, probability of x more than mu plus 5 is equal to probability that x is less than, so it is the same, 0.2. Find conditional probabilities that x less than mu plus 5, provided that x is more than mu minus 5. So conditional probability, we divide probability of intersection by probability of the condition. Probability of the condition is x is more than mu minus 5. So it is this section, and this section is 0.8 because total is 1. Right, so 0.8. Probability that we have intersection of two conditions, which means that x is actually between mu minus 5 and mu plus 5, and probability of this intersection equals 0.6, because 0.2, 0.2, total is 1, so this is 0.6. So 0.6 by 0.8 give us 3 over 4, done. Question 7. Find the coordinates of the points on the curve at which dy by dx equals 0. First derivative equals. Let's differentiate substituting dy by dx equals 0. First, for first term, use chain rule. So when we differentiate first term, we're using chain rule. So first we find differential of y, and then dy by dx, which is 0. So first term will be 0. For second term, we use product rule. And so product rule give us 3y. So when we differentiate by x, 3y squared plus then we differentiate by y and dy by dx. So this is 0 because this is why second term becomes simplified 3y squared. So finally this differentiate will be, so also we differentiate minus x cubed, it becomes minus 3x squared. So we get y squared equals x squared, which means that y equals either x or y equals minus x. So we substitute y equals x into the formula, this formula, and we get x cubed equals 9, which means that cubic root of 9 equals x. Y will be sorry, here mistake, y will be also positive. When y equals minus x, x equals 3, and y equals minus 3. So here we have one mistake. Okay, so answer is this 3 minus 3, and right, done. Question 8. The graph y equals first derivative of f between 0 and 5 is shown in the following diagram. The curve intercepts at 1, 0, 1, 0, and 4, 0, 1, 0, sorry, 1, 0, and 4, 0, and has a local minimum at 3 minus 1. So here local minimum, this is for f prime, f first derivative. Write down the x-coordinate of the point of inflection of y equals fx. So it is for a function y equals fx, and second derivative will have 0 at point 3 minus 1. This is why here we have point of inflection. Second derivative will be at this point, x equals 3. B. Find the value f1 given that f0 equals 3 and the area and the shaded area equals 0.5. So shaded area. So we should find integral of this function from 0 to 1. And integral of f prime is f. So f1 minus f0 equals 0.5. f0 we know it is 3, so we get 3.5. B. Find the value of f1. We found. Now this is B. Sorry. This is B. And this is C, so this is C. Right, so this is B and this is C, so this is, okay, that's strange. B and C. Doesn't matter, okay. Right, so B we found, now C. Find the value of f4. The area enclosed between 1 and 4 is 2.5. 1 and 4, so area here will be 2.5. It means that integral will be minus 2.5. That's attention here. So integral will be f4 minus f1 minus 2.5. So we put so value of f1 is 3. So we get 1.0. D. Sketch the curve from 0 to 5. So actually we know 3 points, and we know that here we have positive first derivative, so it is increasing, and as a result we can draw such a curve. So we have 1 point, another point, and another point. So here local maximum, and by the way, here we have also point of inflection at point 3. So somehow, let's just show it somehow. Point of inflection. Let's not forget that here we have point of inflection. So we will show it somehow. So here point of inflection. How we will show it? Let's show it with triangle. And point of inflection and point C. So all information that we have, we demonstrated on this graph. Finished. Section B. For section B, we need to split screen. And we need to find question. Section B. Okay, question. Show that sine equals right. Okay, square root of sum give us sine squared plus 2 cosine sine plus cosine squared. Sine squared and cosine squared is 1, Pythagoras identity, and 2 cosine sine is sine 2x. So this question is done. Question B. show this identity. So second we turn into 1 over cosine seconds. So we have to add fractions with the same numerator, so we get 1 plus sine 2x. 1 turns sine 2x equals 2 sine cosine theta. It is double angle identity, and 1 expands as cosine squared plus sine squared. So actually we have here cosine plus sine squared. Here difference of squares turns into sum times difference, and we simplify cosine plus sine, we get what is expected. This question is done. C. Hence or otherwise find in the form. Right, so we use hence. So we rewrite this expression and we use substitution. Let t equal cosine minus sine x. dt then will be different first derivative by dx, or cosine plus sine x dx equals minus dt. So actually we can substitute cosine plus sine dx by dt minus dt and this by t. So we get this expression. So the integral will be logarithm t. Then we substitute expression for t, cosine minus sine, and will be minus logarithm of cosine 0 minus sine 0, which is logarithm 1. So this is 0, minus logarithm cosine of 30 degrees will be square root of 2, and sine will be 1 over 2, so we get this, plus 1. So minus of this expression, invert numerator and denominator, numerator and top and bottom values, and then we multiply by square root of 3 plus 1 to simplify. So in the numerator we get 3 minus 1, which is 2. 2 and 2 simplifies, we get this expression as expected. Question 10. The function p is defined this way. Find remainder when p is divided by x minus 2, x minus 3. Remainder at 2 will be the value of this function at 2, which is minus 12. Remainder at 3 will be, for double I, 0. Prove that px has only one real 0. So we rewrite this formula, find common factor x minus 3, and we understand that this expression product is equal to 0 when x minus 3 only equals 0, so x equals 3. So this question is done. Write down the transformation that will transform the graph onto the graph. Okay, here we can realize that y equals p2x. We have stretch parallel to the axis with x equals 0, scale factor 0.5. The random variable x follows a Poisson distribution with mean of lambda and this equation. Find the value of lambda. So they use lambda. In the booklet we have m. So we have section 5.6 Poisson distribution formula. We substitute all values and we simplify by e to the minus m power. As a result, we get cubic equation, which out of which we can extract factor m minus 1.5, and we realize that this expression is equal 0 only when m or lambda equals 1.5. So this question is done. Question 11. Last question. Two distinct lines L1 and L2 intersect at point P. In addition to P, 4 distinct points are marked out on L1 and 3 distinct points on L2. A mathematician decides to join some of these 8 points to form polygon. Find how many sets can be selected which can form the vertices of quadrilateral. So this is a picture. 4 points, 3 points, point P. So we are making quadrilateral, so we should exclude P. So how we form quadrilateral? Any 2 points out of 4 combined with any 2 points out of 3. So combined means multiplication. So we get 6 times 3, 18. For a triangle, we should include P, and then we have 2 of 5 points combined with any of these 3, or 2 of these 3 points combined with any of these 4. As a result, here we multiply. So we get 30 plus 12, 42. The line L1 has vector equation. Okay, let's open. Okay, vector equation like this, and the line L2 has vector equation like this. So here lambda is parameter, here mu is parameter. The point P has coordinates 4, 6, 4. Verify that P is the point of intersection of 2 lines. So first of all, at point P, the values of coordinates are equal, so this is why we equal values of coordinate, and out of this we can find the value of parameters when this happens. So this happens when lambda equals 3 and mu equals 1. And let us find at which point this happens. So for example, let's take L1, lambda equals 3, we get 4, 6, 4. It is exactly this point. So they intersect, and it is point 4, 6, 4. The point A has coordinates and lies on L1. Write down the value of lambda corresponding for L. So parametric equation, coordinates of point, we see that lambda equals 2. Write down PA and PB. That's easy. So point B, point A, and point P. So P will be A minus P, PB will be B minus P, and point C has coordinates 1, 0, 1, and point D has mu parameter minus 2, so we find also point D with parameter minus 2. Substituting, we get these expressions. Find the area of quadrilateral CDB, 8 points. So area of quadrilateral CDB is equal to sum of areas of triangles. Area of triangle is half of magnitude of the vector product of. So for triangle ACB it is CB and CA. For triangle CDB it is BC and BD. Formula booklet gives us formula for vector product. Here you can see the values and the result of the product. Then you should find the magnitude of this vector, which is square root of sum of squares of coordinate. For example, here we should square root of 4 squared plus 6 squared plus 8 squared. The same we do for BC and BD. Product will be given by this formula. So we add these two areas and we get the answer. Paper is over. Thank you very much for your attention.